Hello students, today my topic of discussion is bipolar junction transistor. For the subject Analog Electronics 1 for the diploma course in Electronics and Telecommunication Engineering, and this subject is in the third semester of the course, and also for the subject Fundamental of Electronics, which is in the diploma course of Mechanical Engineering for the third semester of the course. Let us see the course outline. First of all, I will tell you what is a bipolar junction transistor. That is, what is the basic definition of a BJT. Secondly, the classification of BJT, symbolic representations, structure of NPN and PNP transistors, working principle. That is, I will tell you how do these transistors actually work. Let us see. What is a bipolar junction transistor? A bipolar junction transistor, in short we call it BJT, is a three-terminal, three-layered semiconductor device. In bracket you can see it is consisted of either two N-type materials and one P-type material, that is two N-type layers, and in between the two N-type layers there will be a P-type layer for NPN transistor, and if it has two P-type materials and in between the two P-type material there is an N-type semiconductor, then obviously that type of semiconductor will be PNP type of semiconductor. Now let us see the classifications. That is, what are the different types of BJT? BJT can be broadly classified into two types. Number one is NPN and number two is PNP. Then you can see the symbolic representations. The first you can see, the first one is the NPN transistor, and the second one, this one is the PNP transistor. Now, according to their symbolic representation, what is the basic difference between these two? That is, for the NPN transistor you can see an arrow at the emitter terminal and the arrow is outward. And for the PNP transistor, the arrow is still present at the emitter terminal, but the arrow is inward. You can also draw the circuit symbol like this. That is, you can see here, that is like this. That is, at the emitter side you can see I have put the arrow. That is, the arrow will always be at the emitter side. But for the PNP transistor it is inward, and for the NPN transistor it is outward. Remember this one. Now let us see the structures of NPN and PNP transistors. You can see here, this is the structure of NPN transistor. As in the name also, NPN, that is, between the two N-type semiconductors there is a P-type semiconductor layer. Okay, and the symbolic representation you already know. Secondly, you can see it is the structure of PNP transistor, where between the two P-type layers, two P-type semiconductors, there is an N-type semiconductor. And this is the symbolic representation of PNP transistor, you already know. But while drawing the structures of NPN and PNP transistors, some features, some very important points we have to remember. In this figure, you have to also notice that there are three terminals. As I have already told you in the definition of the BJT, that BJT is a three-layer device. That is, there are three different layers of semiconductors, NPN or PNP, and three terminals, that is emitter, base and collector. The three terminals are called emitter E, base B and collector C. Same for PNP. Okay, and the regions are emitter region, base region and the collector region. Same for PNP. Let us understand what are the important points we have to remember while drawing the structure of the transistors. The first point is we have to always remember there are three terminals, as I already told you, that is emitter E, base B and collector C. Second point, the thickness of the three semiconductor regions are not same. They are three layers or regions in the structure, that is emitter region, base region and collector region. Amongst these three regions, the base is the thinnest, the most narrow region, and the collector is the widest. Amongst these three, collector is the widest layer and base is the thinnest one. Last point, apart from this, that is moreover, the doping concentration, that is the amount of the impurity atoms we are adding to make the materials extrinsic type, the doping concentration of these layers are also not same. Very important point, the base region is always very lightly doped and the emitter and collector regions are moderately or medium doped. Lightly doped refers to the doping concentration will be in the region or will be in the range of 10 to the power minus 14